Good evening, this is Ahmed Bahadin. Again, I'm going to explain questions about the application of calculus, maximum and minimum applications in calculus. There is a question here saying that what will be the area of the largest rectangle plotted in a semicircle with a diameter of 20 centimeters. What is the largest area of the rectangle plotted in a semicircle with a diameter of 20 centimeters? Nothing given except this. So this is the semicircle, half circle, and I'm expecting that there is a largest rectangle in it. I give the length of the rectangle, I'm suggesting x and x, so this is going to be 2x, and the width of the rectangle is going to be y. The distance between the center of the circle and a point, which is xy, is going to be the radius. Well, of course, this distance also a radius, and this distance is also a radius. The diameter is 20, so the radius is going to be only 10 centimeters. Now I'm going to take one part of this rectangle and take it outside to take advantage of the relation of Mr. Pythagorean, which is going to relate the x and the y, because this one is also y, and I will make a relation using Pythagorean theorem. So r squared, which is the hypotenuse, equal to the x squared plus y squared. We know that Pythagorean saying that the hypotenuse squared in the right angle triangle is equal to the sum of the other two, of the square of the other two sides. So now I'm going to replace r by 10 and I square it, which is 100, and that's x squared plus y squared. I move x squared to the other side to make it 100 minus x squared. That's going to be y squared, or y squared equal to 100 minus x squared, which means y equal to the square root of 100 minus x squared. Of course, I take the positive part. I cannot take the negative part because it's a distance. And now I'm coming to the area of the rectangle. The area of the rectangle is length times width. And the length I already suggested as a double of x, which is 2x, and this is y. I'm going to replace the y from here, or the y in this equation, from whatever y I got here. So if you take a look at this y here, I'm going to replace this y and make this y instead of the y in here. So I write down that's a 2x times the square root of 100 minus x squared. Since I have this relation, and I need now to take the derivative of the area with respect to the variable x, because I have only one variable in the equation of the area, and that's a major equation. We would like to see the largest area of the rectangle, or the area of the largest rectangle inside the semicircle. So the area can be written by 2x times 100 minus x squared to the power of 1/2. I replaced the square root by 1/2. Now I'm going to take the derivative, so I say that the derivative of the area with respect to the variable x is equal to, since this is the first and this is the second, so we are going to have the first times the derivative of the second plus the second times the derivative of the first. That's how we do the product law in derivative. So the first, which is 2x, times the derivative of the second. What's the derivative of the second? It is 1/2 100 minus x squared to the power of minus 1/2, because you subtract 1 from the power, times the derivative of inside of the bracket, which is negative 2x. We close this bracket, we close this bracket. Now, second term, which is 100 minus x squared to the power of 1/2, times the derivative of the first, which is only 2. Now we are going to simplify this as much as possible, and then we make the derivative equal to 0 at the maximum and minimum point. So let's simplify. We cross this 2 with 2, and now we are going to say that this is equal to x times negative 2x is going to be negative 2x squared times 100 minus x squared to the power of negative 1/2 plus, and I will write down that as a 2 times 100 minus x squared to the power of positive 1/2. That's a derivative. Now if I make the derivative equals to 0, this is the derivative, and I will make it equal to 0 at the maximum and minimum point. At maximum, the derivative is equal to 0. We know that. So now I'm going to rewrite that, negative 2x squared, and I will change the position of this to the bottom. So I'm going to rewrite it as a negative 2x squared, and then I write down here 100 minus x squared to the power of positive 1/2 plus whatever I have here, 2 times 100 minus x squared to the power of 1/2 divided by 1. This is very important step. Now we are trying to simplify and solve for x. In this situation, we need to have a common denominator. Having the common denominator, we need to multiply the bottom and the top by this term here to make a common denominator. So I'm going to write it down inside the circle. The top and the bottom is going to be multiplied by 100 minus x squared to the power of 1/2, 100 minus x squared to the power of 1/2. After that, I will come to this place here now. Let's take advantage of the area left on the board. So I'm going to say that 0 is equal to, now I will keep this as it is, negative 2x squared over 100 minus x squared divided by, well, to the power of 1/2, plus also the denominator is 100 minus x squared to the power of 1/2. But now I'm going to multiply this by this, which make the bracket to the power of only 1, because in multiplication we add exponent for like basis. So 100 minus x squared to the power of 1/2, 100 minus x squared to the power of 1/2 will be 2 times 100 minus x squared to the power of only 1. That's the situation. Now we are going to make one denominator, so this is going to be very easy. 100 minus x squared to the power of 1/2. And we are just going to add the top, negative x squared. That's going to be a plus. We multiply everything inside, and we are going to say that it's a 2 times 100, which is 200, and minus 2x squared. So then after that, we can do the cross multiplication. The denominator of 0 is 1. We make this a cross multiplication. So in cross multiplication, this denominator will disappear. So we are going to have a minus 2x squared plus 200 minus this one here was squared also, isn't it? Yes, it is. And we are going to have minus another 2x squared is equal to 0. This situation is going to give me minus 2x squared from this side and minus 2x squared from the other side. So let's simplify as much as possible. So the answer for these two will be minus 4x squared plus 200 is equal to 0. Well, we can divide now. We can divide now by actually 4, or let's just move this term to the other side to make it positive. So we could say that 200 is equal to 4x squared. And now we divide both sides by 4, so we are going to have an x squared, and 200 divided by 4 is going to give me a 50. This is going to give me a 50. After this, I got the value of x squared, so I'm going to make another part of my board here. Let's organize a little bit. So I have my x squared is equal to a 50. I have x squared equal to 50. So, or in other words, I can also say that if x squared equal to 50, so this means that my x is equal to square root of 50, which can be written also as a 5 square root of 2 if we want to have an exact value. Now, this is the value of x. We substitute the value of x from here inside this to get the value of y. So we say that substitute x equals to 5 square root of 2 in, and let's write it down here, in y is equal to the square root of 100 minus x squared. Well, to be honest, it's going to be easier if we just substitute x squared from the very original one, which is 50. So I can say that y is equal to the square root of 100. X squared is 50, so I'm going to replace by 50. So y is equal to also the square root of 50, which is also can be written as a 5 square root of 2. So I get the value of y and I get the value of x. Now we are going back to the area of the rectangle, and we said that the area of the rectangle is equal to 2x times y. And we have 2 times x was a 5 multiplied here, square root of 2, and this y was also a 5 square root of 2. So we are going to multiply everything together. So this is going to be 2 times 5 is going to be 10 times 5 is going to be 50, and square root of 2 times square root of 2 is going to be square root of 4. So the area is going to be 50 times 2, which is going to be 100 centimeter squared. That's the area of the largest rectangle in semi-circle. This is actually the situation. If you want to change to double this and make an area of the circle and subtract it from the area of the circles to find only the shaded area left, we can do that also, but maybe we can take that as another question for the next time. Thank you so much for being with me.